periodicity, and amplitude. In this section, we are going to show you how to determine the period of a trigonometric graph. We are also going to show you how the trigonometric graph is affected by the amplitude. Before we continue, it is important to know that sine 2x is not the same as 2 sine x. Look at the picture. Sine 2x tells us that x is a double angle. 2 sine x tells us that the ratio is double.
Phoenix. Throw in some numbers into an example.
Have a look at this example. In this example, we want to show that sine 2x is not equal to 2 sine x, and we are given that x is equal to 90 degrees. Let's have a look at sine 2x, which is the expression on our left hand side, or LHS. In the place of x, let us put 90 degrees like this. So far we have sine 2 multiplied by 90 degrees in bracket. Look at 2 multiplied by 90 degrees in bracket. 2 multiplied by 90 degrees, it's equal to 180 degrees. So far we have sine 180 degrees. Use a calculator to find the value of sine 180 degrees. Sine 180 degrees, it's equal to 0. So, our left hand side, it's equal to 0. Let us have a look at 2 sine x, which is the expression on our right hand side. In the place of x, let us put 90 degrees. So far we have 2 multiplied by sine 90 degrees. Using a calculator, we see that sine 90 degrees is equal to 1. Let's now write 1 next to the 2. So far we have 2 multiplied by 1 in bracket. So on our right hand side we have 2 multiplied by 1. 2 multiplied by 1 is equal to 2. So this means our right hand side it's equal to 2. Remember that our left hand side gave us 0. Our right hand side gave us 2. This means left hand side is not equal to right hand side, which in turn means that sine 2x is not equal to 2 sine x.
Phoenix. In this example, what were you trying to show us?
Good question. We have seen that sine 2x is not equal to 2 sine x. Let us equate sine 2x to y, and let us equate 2 sine x to y. So far we have y is equal to sine 2x, and y is equal to 2 sine x. I was trying to show you that the graph of y is equal to sine 2x is not the same as the graph of y is equal to 2 sine x. The 2 in the graph of y is equal to 2 sine x affect the amplitude, and this 2 in the graph of y is equal to sine 2x affects the period.
Phoenix. Please explain amplitude and period. Start by first explaining amplitude.
Let's have a look at amplitude. Amplitude is the vertical distance from 0 to either the minimum value or maximum value. I will explain amplitude in full. Look at the following equations of trigonometric graphs. The first equation is y is equal to a sine x plus q. The second equation is y is equal to a cos x plus q. The third equation is y is equal to a tan x plus q. This letter, which is A, stands for amplitude. In order to understand amplitude, look at the following example. In this example, we are given the graph of f of x is equal to cos x, and we are also given the graph of g of x is equal to 2 cos x. Let's have a look at the first question. The first question wants us to copy and complete the table. Remember that f of x and g of x mean y. So, we can write f of x is equal to cos x as y is equal to cos x. And we can write g of x is equal to 2 cos x as y is equal to 2 cos x. Look at the equations. To complete the second row, we need to put 0 degrees, 90 degrees, 180 degrees, 270 degrees, and 360 degrees in the equation y is equal to cos x. Our completed second row should look like this. Look at the table. When x is equal to 0 degrees, y will be equal to 1. When x is equal to 90 degrees, y will be 0. By looking at the second row of our table, we can tell that the smallest y value is -1. We say the graph of y is equal to cos x has a minimum value of -1. Look at the second row again. The biggest y value is +1. So, we say the graph of y is equal to cos x has a maximum value of 1. To complete the last row, let us put 0 degrees, 90 degrees, 180 degrees, 270 degrees, and 360 degrees in the equation y is equal to 2 cos x. Our completed third row should look like this. Look at the y values. Look at the y values in the last two rows. What do you notice?
The values in the third row are double when we compare them to the values in the second row.
That's true, Digit. Look at this too. This is the amplitude. It is clear that to get the y values in the last row, all we have to do is to multiply each y value in the second row by 2. Let us now look at the next question. Now that our table of values is complete, let us now draw the graphs. Let us start with the graph of y is equal to cos x. Look at the table again. Look at the first and second rows. Let us put a dot where 0 degrees and 1 meet. They meet here. Let's do the same for 90 degrees and 0, 180 degrees and -1, 270 degrees and 0, and 360 degrees and 1. Look at the dots. Let us quickly join the dots. Our complete graph of y is equal to cos x should look like this. Now that we have sketched the graph of y is equal to cos x, let us now look at the table again. Look at the table. Look at only the first and third rows. Look on the graph for a point where 0 degrees and 2 meet. They meet here. Let us do the same for 90 degrees and 0, 180 degrees and -2, 270 degrees and 0, and 360 degrees and 2. Look at the dots. The first dot is a point where 0 degrees and 2 meet. The second dot is a point where 90 degrees and 0 meet. The third dot is a point where 180 degrees and minus 2 meet. The fourth dot is a point where 270 degrees and 0 meet. The fifth dot is a point where 360 degrees and 2 meet. Look at 90 degrees and 270 degrees. They are on the x-axis at 90 degrees, which is here. Y is 0. At 270 degrees, which is here, y is equal to 0. So y is equal to 0 at the second and fourth dots. Let us now join the dots. If we join the dots, our graph of y is equal to 2 cos x should look like this. Please note we used a dashed lines for the graph of y is equal to 2 cos x. The graph with the dotted line or dashed line is the graph of y is equal to 2 cos x. The graph with the solid line is the graph of y is equal to cos x. We can see that the number in front of cosine changes the height of the graph. Look at this graph of y is equal to 2 cos x. This 2 is our maximum value. Look at this minus 2. This is the minimum value. So amplitude is the vertical distance from 0 to the minimum or maximum value. For example, from 0, which is here, to 2, which is our maximum value. The distance is 2. This means our amplitude is 2. Let us have a look at another example. In this example, we want to sketch the graph of y is equal to negative cos x. Look at this equation. Y is equal to negative cos x. Next to cos x, we can put a 1. This means our amplitude is equal to 1. Y is equal to negative cos x will now become y is equal to negative 1 cos x. Let us quickly draw the graph of y is equal to cos x. This is the graph we know. In this case, they did not tell us the domain, so we are going to start at 0 degrees and 360 degrees. Look at the graph of y is equal to cos x. The graph of y is equal to cos x will cut the x-axis at 90 degrees, which is here. It will also cut the x-axis at x is equal to 270 degrees, which is here. Look at these equations. If you look at this equation, you will see that we need to change the sign of each y coordinate. 0 degrees and 1 will become 0 degrees and minus 1. Basically, we need to multiply y coordinate by negative 1. The x coordinate stays the same. We are only changing the sign of the y coordinate. On our graph, let us plot the point 0 degrees and minus 1. 0 degrees and minus 1 is here. Look at this point. 90 degrees and 0. Look at the y coordinate. If we multiply 0 by minus 1, we get 0. So the graph of y is equal to negative cos x will pass through this point. This point is 90 degrees and 0. Let us do the same for 180 degrees and minus 1. Let's do the same for 270 degrees and 0. And let's do the same for 360 degrees and 1. Look at the dots. So far we have a dot at 0 degrees and minus 1. Another one that touches the x-axis at 90 degrees and 0. Another dot at 180 degrees and 1. Another dot that crosses the x-axis at 270 degrees and 0. And finally, another dot at 360 degrees and minus 1. Let us now join the dots. Look at this graph with the dotted line. This is our mother graph. And our mother graph, in this case, is the graph of y. It's equal to cos x. Look at the graph with the solid line. This is the graph of y is equal to negative cos x. We can tell that this graph is a reflection of this other graph on the x-axis. Now that you have worked with periodicity and amplitude, let us see if you can try the following activity.
The first one has been done for you.